Hey guys, welcome back to another Algebra 1 lesson. Today we're going to look at operations with radical expressions. This is going to be a two-part lesson. Today we're going to begin by adding and subtracting the radicands. So first we got to recall, what is a radicand? The radicand is this number here underneath of the square root symbol. So just like with adding monomials, we can add and subtract things with terms. When they have the same variable, like 5a plus 3a, we can add that 5 and 3 together and get 8a. It's the same with radical expressions. As long as the radicand is the same, we can add their coefficients. So we could rewrite this as 5 plus 3 is being multiplied by the square root of 3. This is like the kind of like undoing the distributive property, right? Right now we've got 5 times square root of 3 and 3 times square root of 3. But if we put them together, we can say, okay, well, let's just add 5 plus 3 and multiply that by the square root of 3. So I end up with 8 square root of 3 as my answer. So this allows us to add and subtract. Again, though, we can only do the ones that have the like radicand. It's like adding like terms. So when I'm looking at this first problem here, 4 plus radical 5 plus 3 radical 7 minus 2 radical 5 plus 7 radical 7. I can't combine all of these. I have radical 5s and 7s. I can combine my radical 5s together and I combine my radical 7 terms together, but I cannot say what is radical 5 plus radical 7 without doing a whole lot more work. So thankfully, we've got this commutative property that we've talked about this entire school year that allows me to reorder the terms. So I'm going to put 4 radical 5 and this negative 2 radical 5 side by side. Okay, then I'm going to put, well, notice that I kept the sign that was in front of it. Then I'm going to put my radical 7s together. So I've got a positive 3 radical 7 and a positive 7 radical 7. And then we're back up here to like where we were up here in this previous problem. We can add the coefficients or subtract them, whatever the case may be. So 4 take away 2 times radical 5 plus 3 plus 7 times radical 7, and we see that our answer simplifies to 2 radical 5 plus 10 radical 7. Now, I would encourage you to pause the video at this point and try this next problem. And I am going to be checking notebooks. I really want you guys to be writing this down on a piece of paper. I sang to my class earlier this morning, take take this or write this down, take a little note to remind yourself in case you didn't know. But instead of saying, I love you and I just want you to know, like, I love math and I want you to know. So you need to write this down. I won't sing to you on here, or maybe I will. I don't know. But anyway, I really want you to be writing this in a notebook. So you're seeing it, you're hearing it, you're writing it, you're reading it a second time, putting that information into your long-term memory. Plus, you will have something to look back at when you sit down to try the practice problems to help jog your memory as to what we were doing. So pause the video, try this problem. All right, and there it is. Hopefully everybody came up with the same answer. 14 square root of 19 minus 3 square root of 6. All right, so now we're going to simplify the following. I love this. It's like trying to solve a puzzle. The first thing I look at is none of my radical symbol or none of my radicands are the same number. So I start looking at them and thinking, okay, what can I divide them all by so that I have a similar radicand? Well, it looks to me like all of these numbers are divisible by 3, so I'm just going to start working in that direction. Recall that we can take the square root of 75 and rewrite it as the square root of 25 times the square root of 3. Isn't that the same thing? 25 times 3 is 75. And then notice I can simplify this. Square root of 25 is 5, so I have 5 radical 3. But I can't forget that there was this coefficient here, this 3, in front of my radical symbol. So I've got to, it's 3 times radical 75. So I've got to do 3 times 5 radical 3, and I get 15 radical 3. So I have just rewritten 3 radical 75 as 15 radical 3. Okay, now we're going to try it with this negative 6 radical 48. Well, I know that 48 is the same as 3 times 16, right? So I can break that apart and do radical 16 is 4. We'll keep my negative 6 out here. All right, not sure the last thing I said. I got a phone call. But anyway, square root of 16 is 4. And then we've got still this radical 3. So we can go ahead and combine those. Negative 6 times 4 is negative 24, radical 3. So I'm going to come over here, negative 24, radical 3. Okay, and now radical 27. I know that that's the same as 9 times 3. I know the square root of 9 is 3, so I've got negative 3 radical 3. Now we're going to combine these coefficients. So 15 take away 24, take away 3, and times that by radical 3. So 15 take away 27 is 27, 15, 7. Is that right? Negative 7, radical 3. There is my answer. That's your answer. If you can't do math, if you can do math, you know that 15 take away 27 is not 7, it's 12. Just checking to see if you're awake and listening. Maybe. Or maybe I made a mistake. You'll never know, will you? So negative 12 square root of 3 is my answer. All right, so moving on to the next one, I want to pause the video again. I want you to try this one and come up with your own answer. All right, and there it is, broken all down for you. You can pause the video and read that through. If you made some mistakes, figure out where you made your mistakes and fix them. This is the key part of learning mathematics. It's okay to make mistakes. We just got to analyze and fix them. So your answer should have been negative 83 square root of 2. All right, for our last problem for this video, it says Kate is decorating a rectangular pavilion for a party and wants to string the lights along the edge of the roof. Two of the sides have a length of 13 square root of 5. So she's got 2 of those. And the other 2 sides have a length of 6 square root of 45. So 2 times 6 square root of 45. How many feet of lights will Kate need to decorate the entire pavilion? All right, so we need this to be square root of 5. Well, I'm looking at this and I'm thinking, all right, 9 times 5 is 45. I know the square root of 9 is 3. 3 times 6 is 18. 18 times 2 is 36. And I've got 36 square root of 5. I'm going to break that down one more time. 45 is 9 times 5. The square root of 9 is 3. So now I've got 2 times 6 times 3, which is 36 square root of 5. Okay, over here, 2 times 13 is 26. 26 square root of 5. We're adding that to the 36, so I've got 50, 62. 62 square root of 5 is how many feet of lights she will need. 62 times square root of 5 feet of lights. All right, I hope this made sense. If you have any questions, make sure to contact me, let me know, and I will be happy to help you. Have a great day, guys.